Encoding, an overview. Encoding is the process of converting data from one form to another. In its simplest terms, encoding takes information and transforms it into a format that can be used by different systems or devices. This process is essential for various applications in computing, communication, and data storage. Types of encoding. 1. Character encoding. Definition: this is the process of converting characters, letters, numbers, punctuation, etc., into a format that computers can understand and process. Common types. ASCII, American Standard Code for Information Interchange, uses 7 bits to represent 128 characters, includes English letters, digits, and some special characters. Unicode, a more comprehensive encoding system that can represent characters from almost all written languages. UTF-8, UTF-16, and UTF-32 are different ways to implement Unicode. ISO/IEC 8859, a set of standards for 8-bit character encodings, covering different languages and scripts. 2. Data encoding. Definition: transforming data into a different format for efficient storage, transmission, and processing. Common techniques: binary encoding. Data is represented in binary form, zeros and ones. All digital data ultimately gets converted to binary encoding. Base64 encoding encodes binary data into ASCII characters, making it suitable for text-based systems like email. Hexadecimal encoding represents binary data using hexadecimal base 16 numbers, which is often used in programming and computing. 3. Signal encoding. Definition: converting information into signals for transmission over communication channels. Common techniques. Analog encoding represents data using continuous signals, e.g. AM and FM radio. Digital encoding represents data using discrete signals, e.g. digital audio and video. How encoding works. 1. Source information, the original data that needs to be encoded. 2. Encoding algorithm, the method or rules applied to convert the source information into the encoded format. 3. Encoded data, the result of the encoding process, which can be stored, transmitted, or processed. Importance of encoding. Compatibility ensures that data can be understood by different systems and devices. Efficiency optimizes the storage and transmission of data. Security protects data during transmission by converting it into an unreadable format, e.g. encryption. Data integrity ensures data remains accurate and unaltered during transfer and storage. Examples of encoding in daily use. Text messages. When you send a text message, it's encoded into a format that can be transmitted over the network and then decoded back into readable text by the recipient's device. Web pages. HTML, CSS, and JavaScript files are encoded text files that browsers decode to display web pages. Multimedia files. Images, videos, and audio files are encoded in formats like JPEG, MP4, and MP3 for efficient storage and playback. Challenges in encoding. Compatibility issues. Different systems may use different encoding standards, leading to compatibility problems. Data loss. Some encoding methods, like lossy compression, may lose some original data to reduce size. Complexity. Certain encoding processes can be complex and computationally intensive. Hashed encoding versus encryption. Encoding focuses on transforming data for compatibility and efficiency. It is reversible and not intended for security. Encryption, a subset of encoding designed specifically to protect data by making it unreadable without a decryption key. It is used for security purposes. Summary. Encoding is a fundamental process in computing and communication, enabling the conversion of data into different formats for storage, transmission, and processing. It encompasses various techniques and standards, each serving specific purposes and applications. Understanding encoding is essential for ensuring data compatibility, efficiency, and security in our digital world.